Section 5.2, the definite integral. So what we're discussing today is the definite integral and net area, properties of definite integrals, and evaluating definite integral using limit. And so what is a definite integral? If you remember from the Riemann sum that we did in 5.1, we're using that again. A definite integral of a function f on the interval a and b is the integral. This one is called summation notation, and it's actually, we call it elongated sum. And the elongated sum right here, you draw like that, and then you have this is the bounds on the x-axis. You go from the lower bound to upper bound. Remember, when we were trying to find the area, we would always basically bound the surface, the area under by x values, and so that we would go vertical lines from x values and bound them. And so now this is f of x. F of x is called integrand. F of x is integrand, and then dx. What is dx? Dx has nothing to do with the entire integral part. It's just that nothing to do with the integrand. It has to do with variable. You're taking you're working, basically it tells you what the input is. That's all it does. And it has some meanings beside that, but what you want to do when you're going through calculation is to remember dx is just a sign that you have input x. And so this is going to be limit of the summation I equal to 1 to n, and n goes to infinity of f of xi delta x. Okay, so I said dx has nothing to do with the integrand, but dx is actually the substitute in this sum for delta x. And we've done this before when we were doing differentials, that dx and delta x are similar concepts basically. Delta x is just the one that you use to basically break down the interval, and you have the intervals with delta x, but dx is the sort of what happens to it after the limit has been done. And so again, delta x is b minus a divided by n, and xi is going to be considered as you start from a, and then you move delta x, and then you move another delta x. So every time you move, that's the number of i's that you moved, and then that's how you basically estimate the limit, and that would be the definite integral. Okay, so this is a presentation of that. So you start, like, let's say you have n equal to 5, you break down n equal to 5. What is the delta x? Delta x is b minus a divided by 5. And then every one of these, f of xi delta x is the area of one of these rectangles. Then you go n equal to 10, then you have a little better estimation and a lot more rectangles. N equal to 20, you have 15, you have more, you have 20, you have more, 25. Oh, it's getting really close to that area, isn't it? There are not a whole lot of extras or lowers. And at n equal to 30, you see what it's almost it. It's very close estimate is, and so that's the point of this process. Now, so again, we're saying the definite integral of a function f on the interval a and b is integral from a to b of f of x dx, and it's equal to limit of as n goes to infinity of the summation I equal to 1 to n of f of xi delta x. delta x is being b minus a divided by n, and xi being a plus I delta x, provided that this limit exists. Sometimes this limit doesn't exist. The integral symbol, that elongated s, is an elongated s introduced by Leibniz because an integral is a limit of a sum. And then procedure of calculating an integral is called integration. F of x is called an integrand. A and b are the limits of integrations or bounds of integrations. If an integral from a to b of f of x d of x is defined, we say that f is integrable on a and b. So if f is continuous on a and b, or if f has only finite number of jump discontinuity, then f is integrable on a and b. Well, in Calc 2, you learn, you can do a little bit more, and then in higher mathematics, you learn a lot more methods of integration. It won't be the Riemann integration, but it will be, it's just variations of that, basically. So let's say y equal to f of x is this curve. Now, it's not always above the x-axis. And so what do I do when I'm talking about the integral? When you're saying the sigma f of xi delta xi, that is the area above of where function is above the x-axis minus the area below the x-axis, right? And so in here, when you're doing the sum, you can see it's the estimation of the area above the x-axis. Those are the blue ones, and then you have to subtract, because when you plug in f, the values in the red zone, f is going to be, and f of x for those values are going to be negative values. So you're basically adding up the positives and above the x-axis, and you're subtracting the below the x-axis. So this gives you that the integral from a to b of f of x delta dx is going to be the area above the x-axis, but below the curve, minus the area below the x-axis above the curve. And so basically the definite integral calculates the net area, the area below the positive part, and minus the area above the negative part. And so look at this one. If I don't know how to do this with limits, but I may have other tools in my pocket to calculate integral from -2 to 2 of f of x dx. This is f of x. What's the area between -2 and 2? That would be the area of the circle, the quarter of the circle. The circle is of radius 2, so it's pi, the 4 pi, and you divide it by 4, you get pi. And then there's a trapezoid here. Trapezoid, one side is 2, the other side is 3. 2 plus 3 divided by 2 is 5/2, and then you multiply by 2, you get 5. So it's 5 plus pi, and that's the integral from -2 to 2 of f of x dx. Okay, net area and the total area. So let's say, what's the difference between that? Net area, again, is the area underneath the positive part above the x-axis, minus the area above the negative part below the x-axis. And that's the net area. See, the b plus g minus r is the net area. So if I'm calculating integral from -2 to 3, b is pi, and g is 1 times 1 divided by 2, and minus r is 2 times 2 divided by 2. And so that would be -2. Now, if I want to find the total area, I have to add b plus g plus r, and then I get, basically what you're doing is you're going to be finding the integral of the absolute value of f of x rather than f of x if you're adding all the areas. And so that would be b plus g plus r, which is pi plus